Yeah, hello. Today I just want to solve this question mathematically here on C programming. So, question is all about bisection method, and theoretically we all know about this question. Uh, Once more time, I would like to look after the algorithm. Just starting choosing lower value and upper value so that the product of function lower and product of function upper should be less than zero, and there should be one error precision. After that, we should find a function of lower and function of upper, and as we know, the exam will be xl plus xu upon 2. So the main point is here, if the product of function of xl and function of xm is 0, immediately the root will be xm. So if the function of fxl and xm is less than 0, then xm is equals to xu. So this is all about. So let's do here is mathematically. So let's solve this question on the programming, C programming, okay? So I'm using this BS code. Let's give name this bisection 1. Let's see. Okay. First of all, let's look after this equation. Okay. Let's write this equation here. Do nothing. Just write this equation is 3x square. Uh, 3x. So 3x square minus 6x plus 2 equals to 0. Okay. So now let's start to look after this. Oh, okay, this is my first stream. I will check whether it is running well or not on my phone. Just for a second. I don't know how to delete this. Oh, this is running. Okay, okay, no problem. Let's solve. Let's start. So, let's just first of all, uh, not doing too fancy. Just I should declare one header file for C++, so C stdio.h, and let's also use conio, include conio third. That's okay. So why is there language server? Oh, sorry, it says language server crash. Let's open again VS Code. Sorry. I think now it should work. Now it's work. Uh, let's do the pushes, okay? So for now it is okay. Moving to the next, we should create this function, right? So to create this function, we need some variables. So let's create some variable. I would like to give them as A0 for 1, A2 for next, A3, and all. Let's add after, okay? Now let's create one function. Let's define this function at above. Okay. I would like to keep the return value float and let's give name as a float fun font. So that there will be one dummy variable for x. So in this function there should be return a function. Okay. Our function is what this 3x square minus 6x plus 2. So not let's not give 3x square already here so that we can pass another function afterwards on output. So let's create some differently. I want to keep a3 into x means 3x square. So basically in this a3 we are not giving 3 already because afterward when we terminate this program so that user can input their own value, so that user can input the 4 5 or 6 or some random numbers. So there is something a3x square plus plus a2 multiply x a2 multiply x plus, so basically this is quadratic equation ax squared minus plus bx plus c. Let's not do more fancy. Ax squared plus bx plus, just let's put a0. Okay, I think this is correct. Ax squared, let's put cubic equation, not quadratic, cubic equation, so that the user can keep multiple values plus a1 multiply x plus a0. Okay, now this I just create a function. So just that return this, so that user, this is cubic function. Let's write a cubic function, so that user can pass their own values, not specific within. This user wants to, let's dive into the main function. Okay, on main function I should create something more here. So and then there is all float, so I'm also using float because this is numerical method, answer can be as float. So we need one a lower value, right? Let's do this for free chicken. In this case, we need stats x lower value, x middle value, x upper value, and I need function of xl and function of x upper and function of x middle. Uh, and we need one error. One error is specified already on the question. Let's skip this small error, and we also calculate absolute relative error, right? We should also, let's look for all algorithm per second. So we need to do this process. So we are taking this accelerative error, and in question we, that gives our specific error at the first. So that for that error we are declaring this e. So other is normal. Okay. We are just declaring the variables. After that, let's ask the function for the user. Okay. So let's ask for the coefficient. Please enter the coefficients of this is quadratic equation, so let's ask for a3, a2, a1, and add a0. Okay, so let's do this. After that we need to scan app. User will input four values, and they will input one value, two, three, four value. User will input this one, two, three, four, comma, what will be this time? So let's take this at a1. Okay, so okay, a3. So I will just copy and paste. It will make easier. First will be a3, second will be second, third will be coefficient of first, and last one will be the last coefficient. Okay, let's terminate this line. So till now, just user input the coefficient of the function. So we need to guess the usual, so that we, in the first step doing this theory practically or on the copy, we need to guess first to initial guess, so that that will be negative. While guessing these terms, the answer should be negative. So in this question, if you put lower value of x1 in this function, there will be a positive answer. There will be just positive answer. So while keeping these two, there will be negative answer, so that user should guess to that number, so that the multiple of that number should be negative by putting that number into this function. So ask that also to the user. Printf enter initial guesses, and also ask error at this time. Okay, and error error means so that user will enter that one error, so that, and after that the error will be compared with this absolute relative error, so that if that is a greater than absolute relative error, our program goes run and run again and again. So let's terminate this slide. uh, Finish. Let's ask user to type of scanf. So we are putting this on where? I think we are putting this on here, okay? So initial guess is our XL and XM, okay? Our initial guess is our initial guess is XL. So first of all, user will input the lower, and second, user will input upper. And our next will be our error. Error also. Let's specify error here. This is there will be add, as this is the reference for the input. Okay, now all input is complete. Okay, now let's move to the function. Oh, first of all, we should be let's close the main function. Oh, yeah. Now let's start to go deep. So uh, we just completed the function so that user can input function, error, and all. Just we complete to this is algorithm chart. We complete the third algorithm. So before calculating the one this action, let's look one. Let's calculate that function. Okay. Now user will input this x lower value and x upper value. Now compute the function. So if fxl, so fxl is nothing but just function, just keeping the value on here. Just for example, I mean if fx is equals to 1, just keeping that value of xl 1 until this function. Okay, now let's keep there. So fxl equals to f of function. In this function we are putting value. Okay, so we have already created this function. So in this function we are entering the value xl. That's not doubt here. It's easy. Okay, nothing but just calculating function. We are already created function, just passing that. So let's use fxu equals to fun function of xu. In this also we are calculating this. We already created this function. We are passing the value of x lower and x upper to that function. Okay, now let's calculate fxm. Oh, but before calculating xm, this means middle value. We should calculate the xl. Middle means just x lower plus upper divided by 2. Okay, okay. We just computed this. We just computed up to here. We are up to here. Okay. So we just completed here, and let's calculate fxm also. Fxm is also good, easy. Just passing the value of xm to the function. Okay, let's finish. Now, oh, let's put here one loop while, because it will be easy. While till one, till there is no error. Let's use this. Okay, this means we are calculating just of one root. So basically there is one concept here on bisection method. So if there is if if two functions are multiplied and that is greater than 0, there is no root, or there is even number of root. If that is less than 0, there is odd numbers of root. Since we already did this, since I already know that if these two xl and xu values are put here and that function are multiplied, we will sure get value less than 0. So we know there will be one root, or I don't mean one, but sure there will be odd number of roots. So let's put this while loop here. This is closed for this while. Okay. Okay. Now let's use if loop. We are on the most important loop here. Okay. Let's compare this to our computerically, not theoretically. So check the algorithm. Algorithm, if fxl and fxm is equal to 0, then the answer is adjacent xm. Okay, it's too easy. If fxm multiply fxl is equals to 0. Let's put this inside bracket. Okay, there might be some mistake or incorrect. It will be easy. Is equals to 0. Our answer will be what? Our root will be just x and root is percentage d. Root is percentage d, and that will be and that will be x and finish that will be x. Okay. Let's use another rule. Else if we finish this, okay, I would like to like tick mark. Store. We finished this already. How dark this is. How face this. Uh, if yes, finish this. Okay. Else if let's you enter itself else be fxl. Let's put bracket here also. Fxl multiply fxm is less than 0. Okay, less than 0. If this is less than 0, then our root will be I think there is x, then xu is equals to xm. Xu is equals to xm. Xu is equals to xm. Okay, finish this. Now let's just copy and paste. No, let's create another also. Else, so we should not specify this, since there will be either this condition, or as it is, there will be this. So if there is no this two, there will be this. So not specify something. Directly I can write here. So let's open this bracket also. Xu is equals to XL. No. Yes. No. I think XM. Yeah, there will be XL. XL. XL is equals to XL. Okay. So I'm planning to uploading the video like this to watch the disease. So I will look this video after so that I can. It will be easier to me for remember, right? Uh, so let's complete this. Okay. I think now what's next box is we completed step algorithm 4 also. Let's calculate absolute relative error. Okay, let's what's happening here. Like this 0. Why is this? I don't know why this is not showing here. No problem. No problem. So I completed this. Let's calculate absolute relative error. Okay, absolute relative error. So absolute relative error formula is just I know xu minus x lower value minus no xl minus xu. Oh, no problem. Upon xu. So this absolute. So if there is negative value, as it is, this value will be positive. Since we are doing absolute. Okay, now let's compare. If ERA we completed this also. Now we are in last step 7. If ERA is greater than E, so that if it's greater than we go to step, we again calculate the root. We again calculate the root. So is it already will, if the root is smaller, our answer will be that root. Okay, that root is uh, root is there is typing mistake. Root is percentage d. Percentage f. Oh, that is terribly mistake. I understand this. We are taking floating value and we are creating decimal. So our root will store an accent. Let's break. Let's break. Since there is no any if else or something like that, so I like to break there. My program is complete, so if there is some error, let's look. There might be some error. So I used to work on Ubuntu Linux. This is my first There is saying there is, oh, there is one semicolon. That's correct. I think there should not be error, okay? Let's check, okay? So let's build this. Oh, there is no any kind of kinda. So I like to GCC bisection, GCC bisection, bisection one dot C. Oh, there is no error. I think now there will be error. Oh, there is excluding the coefficient. Okay. So in our question, what is our coefficient? In our question, our coefficient, we didn't have a cubic fraction since I gave their cubic, so we just have e square. Let's just put 0 first. Second is -6. Third is 2. Okay. Our error is, I think there is error is missing. I guess our error is 0.5. 0.05. Okay. Yeah. No, let's be sure. Yeah, our error is 0.05. Yeah. So let's enter initial guess. Okay, this is, I will look after this today. This is for today. So I am using OBS Studio for live streaming. This is my first. I am uploading daily for tomorrow. Okay. And it will stop immediately if you